One for chromosomal mutation. The ads of a diagram show what happens when a female gamete with no chromosomes is fertilized by normal gametes. Female gametes, okay, female gametes with no chromosomes is fertilized by a normal male gamete. So parents, okay, female gamete with no chromosome. So for male gametes, XY, okay, fertilized by XO. So XO is referred to female gametes with no chromosome. Okay, gametes, it will become XY cross with XO. So here, female gamete with no chromosome. Here, female gamete with no chromosome. So what will happen? Okay. So F1, you will get XO and YO. So YO will not survive. It will not survive. Will not survive. Okay. XO, so the daughter will become Turner syndrome. SO is Turner syndrome. So these are the answers. Name the syndrome for the female offspring. So the female offspring here, it will become Turner syndrome. Number 2, figure 3 shows karyotypes of an individual suffering from genetic disorder. So here, this one is human karyotype. Look here. So there are 22 pair of autosomal chromosome and 2 pair of sex chromosome. But look here, at chromosome 21, it have extra chromosome. At chromosome 21, it have extra chromosome. So now, this genetic disease we call as Down syndrome. Okay, why Down syndrome? Because additional of one chromosome at chromosome 21. So how many chromosomes are found in the somatic cell of this individual? Of course, they have 47 chromosome instead of 46 chromosome because additional of one chromosome at chromosome 21. Name the genetic disorder caused by chromosomal alteration as shown in figure 3. So this one we call as Down syndrome. Okay, Down syndrome is belong to trisomy. What is trisomy? Trisomy is when a set of chromosome gain one chromosome. Trisomy is belong to aneuploidy. Aneuploidy. As you know, aneuploidy we have two types. The first one is trisomy. The second one is monosomy. Okay, monosomy when a set of chromosome lost one chromosome. Okay, describe the chromosomal events which cause this genetic disorder. Why? Because of the first one, because of non-disjunction occur at autosomal chromosome. Because of non-disjunction occur at autosomal chromosome. Since extra chromosome at autosomal chromosome. So non-disjunction occur at autosomal chromosome. What is non-disjunction? Non-disjunction is the failure of homologous chromosome or sister chromatics to separate and move to opposite pole during meiosis 1 or meiosis 2. Okay, so now once non-disjunction occur at autosomal chromosomes, so it will form abnormal gamete N+1, and then it will fuse with normal gamete. It will fertilize with normal gamete, and that's why it produce Down syndromes. Okay. Okay, question number 3. In the 19th century, only S. maritima 2N60 could be found in Britain. After 40 years, S. alterniflora 2N62 from America was introduced and interbred with S. maritima to form sterile hybrids. Sterile hybrid is mandul lah. Mandul. So S. townsendi. Okay, so S. townsendi is mandul, sterile. 50 years later, a new generation of S. townsendi has evolved in fertile species S. anglica. Okay, selepas 15 tahun barulah S. townsendi dia evolve, dia menghasilkan spesies yang tidak mandul, yang fertile, kita panggil sebagai S. anglica. Okay, what type of euploidy occur in the statement above? Remember, we have in chromosomal mutation, okay, it will alter the structures and alter the numbers. The numbers differ kepada sama ada aneuploidy or euploidy. Euploidy, we have two types. We have auto ataupun allo. Autopolyploidy or allopolyploidy. Aneuploidy, we have two types, monosomy or trisomy. So autopolyploidy involve only same species. Okay, allopolyploidy involve a different species. Here, what is the difference between aneuploidy and euploidy? Aneuploidy, set of chromosome, either it gain one chromosome or lost one chromosome. So meaning that monosomy is 2n-1, trisomy 2n+1. Okay, so either it lost one chromosome or gain one chromosome. Euploidy have set of chromosome, so it involve a set of chromosome, either 3n, 4n, 5n. So it's very rare in animal. It's only occur in the plant cells. So in these questions, so it involve maritima and S. alterniflora. Okay, S. alterniflora and S. maritima interbreed each other. So meaning that this type of euploidy is alloploidy because involve a different species. Okay, so Maritima 60 chromosome, Altinifera 62 chromosome. So gamete is 30, gamete is 31. So as Townsend, it will form 61 chromosome. Okay, so as Townsend, it have 61 chromosome. Explain why S. Townsend is sterile. Okay, why S. Townsend mandul? Why? Because of since S. Townsend have 61 chromosome, how can it form gametes? Dia tak boleh 30 setengah, tak boleh. Sebab that's why dia tidak boleh menghasilkan gamet disebabkan tiada kromosom homolog untuk berpasangan. Okay, S. Townsend there are no homologous chromosome to pair. Why? Because ni 61 chromosome, so no homologous chromosome to pair. So since there are no homologous chromosome to pair, therefore no gametes are produced. No gametes are produced. Okay, so how can be sterile hybrids S. Townsend be breeds? Okay, how S. Townsend be breeds to produce fertile offspring? So it use one process we call as vegetative propagation. In this process, the number of chromosome will be doubling. So that's why 61, doubling of number of chromosome 61. So 4n122. So it can produce gamete 61. Okay, question number 4. Figure 2 shows the production of offspring P, Q, R, and S when abnormal ova are fertilized by normal sperm. The abnormal ovums arose from non-disjunctions during oogenesis. So now, what is meant by non-disjunction? Non-disjunction is the failure of homologous chromosome or sister chromatic to separate and move to opposite pole. Okay, state the genotype of P and Q. So now P sperm with X chromosome, fused with ovum with 2 XX chromosome. So here is ovum with 2 XX chromosome. This one sperm with X chromosome. Okay, so P, the genotype of P is XXX. Okay, genotype of P is XXX. So for Q, ovum with 2 X chromosome here, fertilized with ovum sperm with Y chromosome. So Y chromosome here. So it will form the genotype XXY. Name the type of abnormality shown by R. So now R Ovum without X chromosome, so meaning that O. Sperm with X chromosome is X, so XO. It will form Turner syndrome. Okay, type of abnormality, Turner syndrome is 2n-1, right? So this that we call as monosomy. Okay, monosomy, Turner syndrome. Or monosomy. If individual R is married to a normal male, can she produce an offspring? Explain why. R is Turner syndrome. Turner syndrome is sterile. So even though they are married, they fail to produce gamete because they are sterile. So the answer is she do not produce an offspring because she is sterile. 6 shows 2 type of abnormality of meiotic division. So now this diagram is referred to non-disjunction. What is mean by non-disjunction? The failure of homologous chromosome or sister chromatid to separate and move to opposite pole. So A, name the phenomenon that causes this type of abnormality. The answer is non-disjunction. Okay, state the type of gamete cell produced by sex. So here gamete will have 2 chromosomes. So gamete is in the end ploidy. This is referred to gamete. So this one N, normal gamete. This one is N, normal gamete. This one is normal gamete, not normal gamete, abnormal gamete because of N-1. This one is N+1. So the stated type of gamete cell produced by Z is either N+1, N-1, or N, normal gamete. Okay, aneuploids individual will be produced when any abnormal gametes is fertilized by a normal gametes. Name the aneuploids condition and explain how they are produced. Okay, aneuploids condition, either it will be trisomy or monosomy. Okay, what is mean by trisomy? Trisomy, okay, happen when N+1 gamete fertilize with normal gamete. Okay, so while monosomy, N-1 gamete fertilize with normal gamete. Okay, name 2 syndromes that can result from the type of abnormality in C involving sex chromosome in human. Okay, type of abnormality here in C, either trisomy or monosomy. So, but involves sex chromosome. Down syndromes do not involve sex chromosome. Down syndrome is extra chromosome at autosomal chromosome. So, there are 2 syndromes that involve sex chromosome. Either Turner syndrome XO refer to monosomy, or N, or Klinefelter syndrome. Klinefelter syndrome is XXY. It's referred to trisomy. Choose a type of mutation. So, state the type of mutation. There are two types of mutation, either chromosomal mutation or gene mutation. This one is referred to chromosomal mutation. Okay, chromosomal mutation. What is the phenomenon that causes the mutation in figure 7? So, phenomenon that causes chromosomal mutation is ultimately by non-disjunction. What is meant by non-disjunction? The failure of homologous chromosome or sister chromatid to separate or move to opposite pole during meiosis 1 or meiosis 2. Identify the cell division stage where mutation occur in B and C. Okay, B because presence of homologous chromosome, called as meiosis 1. Meiosis 1 for B. C, of course, is meiosis 2. Name a syndrome resulting from a gamete with an extra chromosome 21 is fertilized by normal sperm. Here, chromosome 21 is referred to Down syndrome. Okay, so what is the symptom, physical symptom of this syndrome? First, you have a short stature. Okay, and then a wide, rounded face. Okay, dan juga a large protruding tongue. Okay, give two conditions when the whole sets of chromosome fail to separate during cells division. So if the whole set of chromosome fail to separate, so it will form euploidy. Okay, condition of euploidy, there are two types, either autopolyploidy, involve same species, autopolyploidy, involve same species, or allopolyploidy, involve different species. Why this phenomenon rarely found in animal? So euploidy, either autopolyploidy or allopolyploidy, is very rare in animal cells because of the death of gametes. 7, figure 9 shows one type of chromosomal mutation. What is meant by chromosomal mutation? So, chromosomal mutation that cause abnormalities in structures. Okay, in structures of chromosome we call as chromosomal aberration, or the changes in chromosome number, either aneuploidy or euploidy. So chromosomal mutation, so it can cause abnormalities in the structure, in the number of chromosomes. Structure we call as chromosomal aberration. Number, we have two types. The first one is aneuploidy, the set of chromosome, loss or gain one chromosome, or euploidy. Okay, explain how mutation in figure 9 occur. So this one is referred to structure of chromosome. So the abnormalities that cause the structure of chromosome is changed. So this one is referred to chromosomal deletions. Okay, chromosomal deletion. Okay, chromosomal deletion occur when loss of one segment of chromosome. Okay, chromosome deletion, when loss of one segment of chromosome that containing one or more genes. So example is we call as cry-do-cat syndrome, because deletion occur in 5th chromosome, so it can cause cry-do-cat syndrome. Example of chromosomal deletion. What harmful effect may caused by if it is occur in meiosis? So it will produce what harmful effect may be caused if it's occur in meiosis. It's producing a severely altered and potentially non-functional proteins. It producing a severely altered and potentially non-functional protein. Okay, name two types of mutagen that can cause mutation in figure 9. Give an example for each type. So mutagen, we have two types, physical and chemical. Physical, for example, UV light. Chemical, for example, mustard gas. Number 8, figure 13 shows karyotype of an abnormal individual. Name the abnormality of the individual. So all will be autosomal chromosome will be fine, all in a pair, but look at sex chromosome. Sex chromosome, there are extra X chromosome here. There is extra chromosome here at sex chromosome. So XXY. So name the abnormality of individual. For XXY, of course, Klinefelter syndrome. How does the karyotype differ from a normal person? So it will extra X chromosome at sex chromosome. Here, extra 1 chromosome, X chromosome at sex chromosome. Give the number of chromosome in sperm cell of the individual in figure 13. So sperm cell, of course, sperm cell, normal sperm cell is N. So what happened, this individual it will form abnormal sperm cell, because we have XXY, so the sperm will be XY. So XY, XY. So meaning that it will form N plus 1. Okay, give the number of chromosome N plus 1. Okay. Name the type of chromosomal number alteration in figure 13 and state how it's happened. Okay, type of chromosomal number. So type of aneuploidy, either trisomy or monosomy, and this one is referred to trisomy because how and state how it's happened. It's happened when abnormal ovum fertilize with normal sperm. Okay, abnormal ovum here XX fertilize with normal sperm XXY. That's why Klinefelter syndrome is produced. Number 9, figure 7 shows formations of polyploidy in plants. So plant A, we have the 2n is equal to 16, plant B is equal to n is equal to 16 also. Okay, now gametes is 8, 8. So plant C, it will have 8 plus 8, n plus n. Okay, because of a different plants. Okay, so why plant C is sterile? Because of no pairing of homologous chromosome. Okay, so just how sterile plant C can reproduce. So how to make the sterile plant to reproduce or to become fertile. So there are one process we call as vegetative propagation or reproduction. Vegetative reproduction. So how sterile plant C can reproduce by using vegetative reproduction. Okay, how does process X produce fertile offspring? Okay, so process X produce fertile offspring by doubling the number of chromosome, doubling the number of chromosome. Okay, so how it's double the number of chromosome? Okay, non-disjunction occur to all chromosomes. Since non-disjunction occur at all chromosome, so it can doubling the number of chromosome. Describe reproductive character of plant D. Since plant D is fertile, so it have homologous chromosome. The first one, it have homologous chromosome. So the number of chromosome will be, this one is 16, doubling the number of chromosomes. So plant D must be 32. So number of chromosome is 32, and also the last one is able to produce gamete. Remember, sterile, it cannot produce gamete because it don't have homologous chromosome. Fertile, it have homologous chromosomes, so it able to produce gamete. Apart from the process shown in figure 7, suggest another methods on how plant can be formed. Okay, so how plant can be formed by unreduced gamete plant A and plant B. Okay, so the gamete itself is 16. Okay, union of unreduced gamete of plant A and B. Here supposed to be n equal to 8, n equal to 8. So another method selain vegetative propagations is you just unreduce the gamete in plant A. So meaning that the gamete will be 16 also. That's another method. Who shows the type of chromosome aberration? Define chromosome aberration. Chromosome aberration is a change in chromosomal structure. I repeat again, there are two types of mutation in chromosome. The first one based on the structure, we call it as chromosome aberration, and the second one is chromosomal number, either aneuploidy or euploidy. So define chromosomal aberration is a change in chromosomal structures. Okay, identify chromosomal aberration S and T. So S is, I think it will be here. S is referred to inversion, and T, of course, it lost a segment of chromosome and then it break off and join back again. So the T is translocation. Okay, state two differences between chromosomal aberration and T. Okay, translocation involve two chromosome. Inversion only involve one chromosome. Okay, the first one. Okay, for the second one, inversion. Okay, inversion involve a segment of chromosome. It break off and reattach in reverse order. While T involve a region of chromosome breaking off and rejoining to a non-homologous chromosome. I repeat again, for S, it break off. After break off, and it will be reattached to the same chromosome. But for T, it break off and rejoin to a non-homologous chromosome. Okay. Okay, S involve one chromosome, while T involve two chromosome. Okay, S break off and rejoin or reattach to same chromosome, while T break off and rejoin to a non-homologous chromosome. That the differences between inversion and translocations.